starting on page 6 of this note packet, we are going to work through several of the problems that you saw in example 5, okay? So all we did in example 5, if you think back to it, that was the example with 11 different scenarios. We just read through each one and identified it as either a compound interest problem or a future value of an annuity problem, okay? So now we're actually going to go back and solve each one of the problems, okay? And we're going to work through the compound interest problems first, okay? And then we'll go through the future value of an annuity. We'll work through those problems later, okay? That way we get practice working with each formula separately, okay? As we go through each of these, I will remind you why we decided on the formula we chose, okay? So at the top of page 6, okay, this is telling you that we are going to specifically focus on compound interest, and it tells you for the following problems, use the formula A equals P times 1 plus R over M raised to the M times T to solve each of the following problems, okay? All right, so let's take a look at example 6, okay? All right, so we have, let's see here if I can scroll up. Okay, example 6. Find the total amount due on a loan of $17,500 at 8.5% for 6 years, 9 months if the interest is compounded weekly. How much of this is interest? Okay, read through the problem, okay, again and again until you feel comfortable with what you're given and what you're being asked. Okay. All right, this was example 5D, okay? So if we flip back to example 5D, let's see what page that was. Let's see, here's example 5. If we look at example 5D, there it is. We chose this to be a compound interest problem, okay? So that's why I have it listed as far as using this formula right here, okay? All right, let's rehash why this is a compound interest problem, okay? So here you're not saving money, you're actually making a loan, okay? In this class or in this chapter, okay, you are going to have basically two types of loans. Either it's going to be a simple interest loan or it's going to be a compound interest loan, okay? There are going to be no other types of loans, okay? If you scan through this problem, you do not see the phrase simple interest, okay? You do see the phrase compounded weekly, okay? So this makes this a compound interest loan, okay? Remember why it's compound interest and not an annuity, because you're borrowing one lump sum of money, okay? So you're borrowing the $17,500, okay? So this is a compound interest loan, so we will use the compound interest formula, okay? So we need to figure out, which variable we're looking for, and we need to identify the values of all the other variables. Okay, so remember, you can solve for any one of the variables as long as you know the values of the other variables. Okay, all right, so let's see. It says find the total amount due on the loan. Okay, so basically, if you kind of just think about it, you're borrowing $17,500. The interest rate is at 8.5%. You're borrowing the money for 6 years and 9 months, and the interest is compounded weekly, okay? You're actually finding two different things. You're trying to find the total amount due on the loan as well as the amount of interest. Okay, let's deal with the total amount due on the loan first, okay? So I'll write over here, let's first look for the total amount due on the loan, okay? So in that case, that means we're looking for A, okay? When you're looking at this formula from a loan perspective, P is the amount of money that you borrow. So P would be $17,500, okay? And then A would be the amount that you pay back, okay? So that's how this formula works if you're looking at it from a loan perspective, okay? P is the amount you borrow, A is the amount you pay back, okay? So R is going to be the interest rate as a decimal. So convert 8.5% to a decimal. So it's going to be 0.085. Okay. ILM, we see the phrase compounded weekly. Okay. So that means ILM is 52. Okay. And then time, remember time has to be measured in years, but it's given to us in years and months. You have to turn that combination into a yearly amount. So remember how we handled something like this previously, okay? So what we did is we first handled 6 years and we said, if you have 6 years, there's 12 months in a year. So that is 72 months, okay, in 6 years. And then we added the 9 months, okay? So 72 plus 9 is going to give you 81 months total, okay? You don't want to use 81 as your time value, okay, because that would be 81 years. So you have to say that your time is 81 divided by 12, okay? So that's 81 months, okay? So that's what we will be using as our time value, okay? All right, so we can go ahead and plug everything into our formula. Okay, we're solving for A, plug everything else in. Okay, so this is what it's going to look like if you plug it in. Okay, so here we go. There you go. Okay, so there you go. So now we just need to go straight to our calculator and punch this guy in. Okay. Just so we're clear, because I forgot to mention this, if you wanted to go ahead and do 81 divided by 12, okay, that's a nice clean decimal. It cuts off. So if you would rather use 6.75 as your time value, then go ahead and do that, okay? You might like that better than the 81 over 12, okay? It doesn't matter. Either way you use it, 81 divided by 12 or 6.75, you should get the same answer. I'll go ahead and just change it. The decimal might be a little easier to use here. Okay, I'll change it to 6.75, but you should get the same answer either way. Okay. All right, so let's go punch this guy into the calculator. You're going to punch it in exactly like you see it. Just make sure if you've got an older calculator that the entire exponent is in parentheses. Okay. All right, so here we go. Go over here. Let's clear this out. All right, so I'm going to get 17,500. Open my parentheses, 1 plus 0.085 divided by 52. Okay, close the parentheses, raise it to the power. Your exponent, make sure if you need it in parentheses, do it. It's the m times t power. Okay, all right. So that is what this is how you should enter it into the calculator. You can enter it in one swoop. Okay, so hit enter. Okay. Here comes your answer, okay? And remember, we are dealing with dollars and cents, so you're going to have to round this answer to the nearest cent. Okay, so let's go ahead and go record this answer, okay? So this is going to give us that A is this decimal. Okay, so let's go ahead and round. All right, so we've got 38 cents. We've got to look at the number that comes after it. It is a 7, so we need to bump it up. So the total amount that we have to pay back on the loan is $31,046.39. Okay, so that's the total amount due on the loan. Okay, so that's the answer to the first question. Okay, so the second part of the question says how much of this is interest. Okay, right here, how much of this is interest? So we're going to go and figure that out in just a second, okay? So what I need you to keep in mind, okay, this is not a simple interest problem, okay? Your first thought may have been, okay, interest is principal times rate times time, okay, PRT. That's what I learned in section 3.1. That formula, I equals P times R times T, is only for simple interest, okay? You cannot use it here, okay, because this is compound interest. Okay, so if you plug it into I equals PRT, you're going to get an incorrect answer. Okay, so this is how this is going to work. Okay, because there is no formula for interest for compound interest. Okay, you're just going to have to use your everyday experience with money to figure this out, okay? So here we go, okay? We calculated that at the end of 6 years and 9 months, you're going to have to pay back this amount of $31,046.39. Well, how much did you borrow? $17,500. Subtract it out, okay? So if you take this total amount that you have to pay back and subtract out how much you borrowed, that's how much interest you ended up paying, okay? So for the second part, the total interest that you pay, you get by taking the total amount you pay back, subtracting out what you borrowed, okay? And this is going to be the total amount of interest. Okay, so let's go do that. You're going to take your $31,046.39 and subtract out the $17,500. Okay, boom. Okay, you paid $13,546.39 worth of interest. Okay, depending on interest rates, you can often pay a hefty amount of interest. Okay, it's just a fact of life. Okay, all right, so the amount of interest, I'll put I, this is going to be $13,546.39. Okay, so there you go. Okay, so again, I equals P times R times T only applies to simple interest. Okay, all right, let's take a look at example 7. Before we do that, real quick, let me just remind you, and this applies not only to example 6, but for everything. This is money. This is something that we are all familiar with. We use money every day, okay? When you're solving any type of problem, just try to reason through it. Is this a sensible answer, okay? So like, you know, when we did this first part and we did the total amount due on the loan, okay? $31,046.39. That is a number bigger than 17,500. Okay, say you would work the problem and you got a number smaller than that. Okay, that doesn't make sense. How can you owe something smaller than $17,500? Okay, you know, like I said, you may not have a whole lot of experience with making loans or things like that, but interest can be hefty, especially if you're borrowing money. Okay, so all I'm saying is, you know, these are dollars and cents, stuff that we're familiar with. Try to reason through, does my answer make sense? Okay, all right, let's move on to example 7 now. Okay, so here we go. Okay, example 7. How much should Tom set aside now at 7.9% compounded quarterly in order to purchase a $33,000 motorboat in 5 years? Okay. All right, so again, this is a compound interest problem, okay? It is under the directive of using this formula to solve the problem, okay? This is actually, if we flip back to example 5, this is actually example 5B right here, okay? Where Tom set aside the money for the boat, okay? So I'll go ahead and write that on there in case you want to refer back to it. So this is example 5B, okay? And like I said, when we were over there, we decided that it was indeed compound interest, okay? So again, let us remind ourselves as to why this is a compound interest problem as opposed to a future value of an annuity problem. All right, so what's going on here is Tom wants to save up for a motorboat, okay? So he is going to save money at 7.9% interest. The interest is compounded quarterly. His goal is to save $33,000 in 5 years, okay? And the question is asking, how much should he set aside now, okay? So the way you read that phrase, what is implied is that Tom is setting aside this one lump sum of money, and he's going to let it sit there and accrue interest for 5 years, and he's going to hope to come back and have $33,000 to buy his motorboat. Okay, so since he's saving this one lump sum, that makes it compound interest. Okay, all right. So let's talk about the variable we're looking for and the ones that we know. Okay, let's get the easy ones out of the way here. We know the interest rate is 0.079. The interest is compounded quarterly, so M will be 4. Okay. The time, he's going to save the money for 5 years, so time is 5. Okay. So now we've got this other number, 33,000. So it comes down to, is this the A or is it the P? Okay. Concentrate on what you're being asked. Okay. So when you look at this, okay, again, look at the question here. It says, how much should Tom set aside now? Okay, so again, when you read this, we need to figure out how much he wants to save, put in the bank right now so that it will grow and he will have an account balance or a future value of $33,000. Okay, so we're trying to figure out the P value, which is the amount of his initial deposit, and A is the amount he wants to have in the future. Okay, if you remember, in an earlier video, we discussed how you could think of P as the present value, like right now, and then A was the future value or your account balance in the future. Okay, so we're trying to figure out how much should he invest presently to have a future value or an account balance of $33,000. Okay, so that's our variables. Okay, so we're going to go ahead and plug everything in. Okay, so we're going to get A is 33,000. Okay, that's got to equal the P value, which we don't know, so we're just going to leave it as P, times 1 plus the R value divided by M raised to the M times T. Okay, so that's how you set it up. Okay, now we need to solve it for P. Okay, so P is right here. Okay, you want to get it by itself on one side of the equation. Okay, P is being multiplied by all this stuff in parentheses. Okay, so what I'm actually going to do is go to the calculator and I am going to plug in the 1 plus 0.079 divided by 4 raised to the 4 times 5 power. I'm going to plug in this quantity right here that the P is being multiplied by. Okay, all right, so here we go. I am going to rewrite this, okay? And I've told you this before. Keep writing your work, okay? One step at a time. Do not try to do everything at once. You will likely make a mistake if you do that, okay? But if you do it step by step, write everything out, take it slow, you're less likely to make a mistake. Okay, so we're going to have 33,000 is equal to P times, let's go figure out what P is being multiplied by, okay? So go to my calculator. Let's go ahead and clear out the last problem. Okay, so I'm going to type in what P is being multiplied by, exactly like you see it. So it's going to be parentheses 1 plus 0.079 divided by 4, close parentheses, raised to, you can do the exponent in your head, 4 times 5 is 20, but again, if you didn't, make sure the entire exponent is in parentheses if you need it to be on your calculator. Okay, so this is going to be the quantity that P is being multiplied by, and you need to carry all of these digits, okay? Because if you round now and like you only wrote down 1.48, you're going to be off by a few cents, and that's not good. Banks have to be accurate, and so do you, okay? So let's go ahead and write this number in. Okay, so this is going to be P times 1.478680276. Okay. All right, so again, you're trying to get P by itself on one side, okay? So P is multiplied by this decimal, okay? So to undo that, the opposite of multiplication is division. So we're gonna have to divide off this number. And if you do it to one side, you're gonna have to do it to the other. All right, so then on the right, you have this decimal on the top and in the bottom, they will cancel out and leave you with P, okay? So we need to go to our calculator and do 33,000 divided by this decimal, okay? And that will give us our answer, okay? So let's go ahead and type in 33,000, okay, divided by, okay? You need to divide it by this 1.47 blah, blah, blah number, okay? You can type it in again if you want, okay? You might make a mistake, but you are more than welcome to type it all in. Just make sure you carry all the digits. The easiest thing to do, and you're going to have to follow my cursor because I can't write on the calculator, If you see the second button, see this blue button right here where my arrow is spinning, okay? And then the combination, if you look at your, for me, it's on the negative key. So down here above the negative key, it says ANS, and that stands for answer. It's talking about the previous answer. So if I hit the second or the blue, the ANS is in blue, so that means I have to hit the blue key first. So if I hit second ANS or the second negative key, it's going to bring that up. And so what that's doing is it's taking 33,000 and it's dividing by the previous answer, which is the 1.478680276. So I don't have to retype, okay? And if I hit enter, I will get the answer, okay? So that ends up being how much Tom needs to invest, okay? All right, so let's go write this down. Okay, so we got this number. All right, and again, this is dollars and cents. So to final answer, okay, you can't leave it like this. It needs to be dollars and cents. So we need to round to the nearest cent. Okay, so we have 19 cents. We look after the 19 cents, there's a 7, so we need to bump it up. So Tom needs to set aside $22,317.20. Okay, is this a sensible answer? Yes. Okay. He wants to have $33,000 in 5 years. Okay. So the answer needs to be a number that is less than $33,000. Okay. Saying you had solved this problem, you got something bigger than $33,000. That wouldn't make any sense. Okay. Why would he be investing? Because he'd already have the $33,000. Okay. This is a sensible answer. Okay. So that is how you do this particular problem. Okay. All right, let's go ahead and take a look at example 8.